So some of you may have already met Torsten in the course of the last days. Torsten Hothorn is a professor of biostatistics at the ad personam at Epidemiology, Biostatistics and Prevention Institute at the University of Zurich. He received a diploma in statistics from the University of Dortmund in 2000 and a Doctor rerum naturalium, in 2003 from the same university. From 2000 to 2007, he worked as a PhD student and later as a postdoc and lecturer at the Institute of Medical Informatics, Biometry and Epidemiology at the Friedrich-Alexander-University Erlangen-Nuremberg. In 2007, he accepted a position as Professor of Biostatistics at the Statistics Department of the LMU in Munich. Since April 2013, he's a faculty member of the Medical Faculty and the Faculty of Science at the University of Zurich. Torsten is an ordinary member of the OWL Foundation for Statistical Computing since 2014, and an elected member of the Academia Europaea since 2022. Currently, he serves as a co-editor-in-chief of the Journal of Statistical Software and as an associate editor of the Statistical Methods in Medical Research. Let's welcome Torsten.
Thank you, Audrey, and I want to thank the organizers for inviting me. I was very quick at accepting this invitation, but then I realized how hard it is to come up with a suitable topic and the mode of presentation for such an audience here. And I also realized when looking at the schedule that I have the duty to keep you from taking a nap before dinner. So I settled for a bit more catchy title, and I'm actually going to start this presentation by going outside my own comfort zone, because I have been trained as a statistician, and many of you have been trained as statisticians, and the rest of the auditorium probably identify as statisticians. So we try hard to prevent biases from happening, or we try to eliminate them once they happened on a daily basis. And on a good day, we can maybe look at ourselves as incarnations of Popper's objective rationalist. What does the objective rationalist do? The objective rationalist tries to eliminate bad hypotheses. This is how science progresses, right? We have a hypothesis, we try to get rid of it. And we are doing this in an empirical data-driven way, of course. So for the next, not quite an hour, because I'm slowly crawling back to the objectivity that I like, I will violate this principle and give a subjective and therefore personal and therefore biased and therefore probably incorrect account of some things I thought might be interesting. And I picked one of the packages that I maintain as a red thread through this presentation. So this package is called MVT norm, and at its core, it computes multivariate normal probabilities. So we have the probability that the multivariate normal random variable is between two vectors, and the parameters of this distribution is the mean and the variance-covariance matrix here written in terms of a Cholesky factorization. And then we have this nasty integral. And this integral is very hard to evaluate. There's no analytical solution. So this package gives you a function P for probability multivariate normal distribution, where you can put in the lower and upper bounds and the mean and the sigma for unstructured covariance matrices. That's important. So there are special solutions for structured covariance matrices in relatively large dimensions. So large meaning a couple of dozens or maybe 100, up to 1,000. Okay, so that's the core of this package. And the history of this package starts very early in 1992, so even before R was founded. So Alan Gentz, who was a professor of mathematics at the Washington State University in Seattle, published a paper in the second volume of the Journal of Computation and Graphical Statistics. And the core idea is to use this Cholesky factor to transform the integral in a way that it becomes an integral over the j-1, so you're sparing one dimension, hypercube, and then to use quasi-Monte Carlo methods to evaluate or to approximate this integral, actually. Okay, so this is the first paper. And then he teamed up with Frank Breetz, and they extended the algorithm to the multivariate t-distribution. And what they had in mind, or why did they dive into this? They wanted to provide better statistical procedures for multiple testing and simultaneous inference in the normal linear regression model. Okay? And this paper was published in 2002 in the same journal. And in 2000, this package was published, November 14 to be more precise. And thanks to the archiving feature of Siren, I could go back, fetch the original source file, extract the description file, and the description file says, okay, this is this package, and the software was written by Alan Gens and Frank Breetz, and there was a guy doing an R-port. Okay, so, and I want to think a little bit or reflect a little bit on why did this happen in the first place and what were the consequences. Okay, so I tried to connect to my former self, but I didn't get an answer in time, so I'm left speculating a little bit. I was a first-year PhD student, and I had all the time of the world on my hands. So 25 years ago, there were no PhD committees. There were no status reports to be written and submitted. There were no social or transferable skill courses to be attended. I leave it to you, to your own judgment, whether or not this was a good thing in my case. And I was very lucky with my supervisors, so both my PhD supervisor, Bertolt Lauser, and also the head of the department, Olaf Gefeller, gave me a lot of leeway in actually pursuing what I saw fit. And so how did I learn about this algorithm? Well, it was very easy because my father was Frank's PhD supervisor. And I had been lobbying for quite some time to my father for R at family dinners, and I could imagine that this might have played a role, so maybe I just wanted to make a point here. On the other hand, in the year 2000, software and especially user interfaces to existing software was just not considered research output. So the Journal of Statistical Software was there, but it was maybe not that well known. Our news had just been funded by Fritz and Kurt and other publications when it just gained speed. Open science was way behind the horizon, and I was explicitly warned by people that pursuing such fields wouldn't land me a job later on at the pharmaceutical industry. 2 days after the package was published, Alan Gens wrote an email saying, oh, well, thank you for your work here, and it sounds like a good way to let more people know about the software. And, well, we can now test his predictions. So I never, unfortunately, met Alan Gens personally, so I'm just using this picture from Google Scholar here. And, well, this paper was his most cited paper, or is his most cited paper. So Alan was retired in 2018. And the second rank is a book that he wrote with Frank Breetz on the multivariate normality probabilities. A very nice book, so if you're interested, you should definitely get a copy. And rank third is already this package. Okay, so he was right on spot. And well, at least if we believe Google Scholar citation counts, I will present some more, not to brag about how great things are and were, but just to give or put a number on what the impact of creating an R package might have been. Well, this conference very clearly demonstrated that the times have been changing. So my own university, University of Zurich, has published an open science policy, and one of the paragraphs reads, UZH expects code and software created by its researchers to be shared with an adequate open source license. Okay, so that's a major change in the way that software is regarded. Funding agencies consider software research output, at least in Switzerland. And of course, we have the Journal of Statistical Software, the R Journal, Journal of Open Source Software, and others, where we can actually publish and discuss about software in an academic way. And well, the presentation by James, I think, just illustrated that now R gets you a job at the pharmaceutical industry, maybe in Basel, and maybe also worldwide. Okay, but there are also, well, other developments. So such software as research output means that it's subject to bureaucratic scrutiny as a learned the hard way over the last year. And the fact that CRAN now carries DOIs for all the packages is one outcome of this exercise. And as a package maintainer, with facing a package or maintaining a package with more than 1,000 reverse dependencies, this gives a couple of headaches when you want to update the package, because it's almost guaranteed that one of the downstream reverse dependencies will break if you change something. So I was lucky a couple of weeks ago, so I set up a new version of the package, pushed it to CRAN, and the outer check service was happy. So I was very happy that Uwe didn't have to interact, at least on this occasion, with me on the publication of this, an update of this package. Okay, so how was package life? Well, it started as a simple R interface to the code that Frank Bates and Alan Gens wrote. And this original code is just a classical monolithic Fortran program, right? You start in line 1 and then you end in line, I don't know, 1,300 something. Over the time, I started replacing parts by the R API, so the way that random numbers are generated or the normal probabilities are evaluated. And other people chipped in. So we received code donations from other people. Tetsuhisa Miwa, for example, donated his code. And others added features, for example, random number generators for the multivariate normality distributions, densities, and so on and so forth. And a year later, we published a paper in then our news, now our journal. And the last paragraph says, okay, this is the package, and we're happy that people can use it now. But the last couple of words are important because they again highlight that the primary goal was to equip people with algorithms for multiple testing and simultaneous inference. So that was the use case that Alan Gens and Frank Bates had in mind. So, and then, of course, it became not just a technical, but also a social enterprise in some ways. So other people contributed code. Tetsuhisa Miwa already mentioned it. Xufami wrote code that interfaced this code by Tetsuhisa. Fritz Leisch contributed, Fabian Scheipel from Munich, and Björn Bornkamp from Novartis, and Martin Mechler, who is here in the first row. Well, when I first drafted the slides, I thought it would be a good idea to start with a quote by Winston Churchill, but it didn't fit right. So actually, I had to rephrase it a little bit. So there were, of course, bugs. There were unintended applications that we learned about. There were feature requests and a lot of benefits for myself and also for others. And I want to use the next couple of minutes to illustrate these points a little bit. So last year, I was spending my summer vacation on the beach and received an email from Oxford. Actually, I didn't read the email at the time because I was sitting at the beach and then I don't read emails. I read the emails when I came back to my office. But seeing the subject raised my blood pressure already. And for those of you who haven't seen these emails yet, so the structure is as follows. So the subject says, okay, you are in trouble. Okay, and the first line says, okay, this is where the trouble actually comes from. So one of the checks failed somewhere. And then there is a very crisp and dense explanation of what the problem might be. And typically it's spot on. Right? You probably don't understand it by reading it first, but at least in hindsight, it's clear that Brian was, of course, right. And then it ends with a bit of a nasty sentence because it says, okay, correct the problem or you're out. And of course, in this case, last year, I was a good citizen. I immediately fixed the problem, uploaded a report, already uploaded the new version of the package. And I have to admit that I always wondered if the CRAN maintainers would actually pull the rug from 100 or 1,000 packages and even more because of a Fortran compiler warning. And so this use R was very informative for me, because yesterday morning a prominent member of the R core team insinuated, so I interpreted his presentation in a way that there is an internal too big to fail status. So maybe next time I can go on without actually raising the blood pressure too much. And then we learned about unintended applications. So keep in mind, or at least Frank and Alan started out with this multiple testing business, and immediately people started misusing the package, so to speak. So very early, Timothy Johnson wrote an email saying, oh, well, that's cool software, and I use this function to compute polychoric correlations via maximum likelihood. So he set up a likelihood function, and internally in this likelihood function used the PMV norm we have already seen to evaluate the corresponding contributions to the likelihood. And this was never intended, and it can't really work well, because the whole design and the implementation of the algorithms do not have this application in mind. But we keep this in mind, okay? We will come back to these tetrachoric correlations in roughly half an hour. And then people write these friendly emails saying, oh, this is a great package, but could you maybe vectorize it? Okay. And other people write, okay, that's good, it's nice. This is, by the way, a good way of getting the attention of a package maintainer. So when you don't start complaining right away, but you spend one sentence saying, okay, this is a great package, thank you for your contribution. So at least for me, this typically does the job that I read the whole mail. So it would be nice if the user could pass the Cholesky factor rather than the covariance matrix. And this makes absolute sense. When you're looking at this function as a function that should go into an optimization procedure. Okay, the answer to all these feature requests back then was, yeah, well, I understand, but it can't really be done, because we have this monolithic Fortran implementation, and it's basically impossible to change anything, because it had been optimized for a specific purpose. Okay, but we will come back to these issues later on. And then the benefits. So I personally benefited a lot from having access to this package. Something that I didn't envision when I started with this project. And I'm going through three packages that heavily depend on MVT norms. So the first one, Multcomp, as the name already suggests, is actually a friendly user interface for people who are interested in multiple testing and simultaneous confidence intervals. So the package basically gives you a function which is called GLHT for generalized linear hypothesis, and then you just throw in a model, and it's relatively generic, so it can be a Cox model or a GLM or whatever. And then you specify a multiple comparison procedure, so you could, for example, compute Tukey's honest significant differences or what else. And then this function does the legwork. And the interface is relatively simple, so the CoF and VCoF methods are basically the means of communicating with the model, and then everything is processed, and then some probability or quantile is computed. And just to give you an idea of how important this is to many people, we wrote a paper in 2008 just introducing this package, and it received 13,000 citations. Just to put this in context, the original Bioconductor publication from 2004 has 14,000 citations. Okay, so there are obviously huge communities out there where every time they write a paper, they put an adjusted p-value or adjusted confidence interval somewhere, and thanks to the citation function in R and them being good citizens, all these citations have been generated. Okay, so, and as I already said, I don't have a picture with me and Alan Gens, but I do have a picture with me here and Frank Breetz sitting next to me. And the two other people in the picture are in the room. So Achim Zaleis is here, he's a fellow editor of the Journal of Statistical Software, and our president of the R Foundation is also there. Picture was maybe taken in 2003 or 2004. Okay, and then another package for conditional inference or permutation tests, COIN, computes minimum p-value adjusted procedures based on a very general form of a test statistic which was invented by Strasser and Weber in a paper that Kurt kept pushing towards me for a couple of months, years maybe. And then eventually I realized, okay, this is something that may have some potential. So the interesting part here is that this is a multivariate statistic, which is then collapsed into a test statistic. And these two functions here for two sets of vectors of random variables can be very, very generic. So you can compose statistical procedures in this framework that fit the analysis problem. Right? So, and that's very important because you're not constrained by something that somebody has actually implemented, but you can invent your own test procedure if you want. And if the dimensionality is larger than 1, then it's very likely that the p-value comes from MBT norm. And again, the corresponding papers here received some attention. And this is Achim again. And Kurt, probably discussing or engaged in a heated discussion about the design of this package. It seems I already gave up. I was just busying myself taking notes. And nevertheless, we managed to bring this package out. And then again, something else happened because I ran at the user conference into someone who was really interested in what we are doing. And this is Henrik Venel in the second row here. And he cleaned up the mess that we left with this package since many, many years. And I didn't have a picture of him until the day before yesterday. So this was actually... Okay, and then finally the party package, party for recursive partitioning. So it implements a specific weird flavor of random forests called conditional inference forests. And here it is coupled with a function for unbiased permutation variable importance. So the original variable importance invented by Leo Bremen and Adele Cutler have the problem that they favor numerical variables. Right? So if you have a numerical variable, this is automatically scoring higher than, let's say, an ordinal variable. And this notion here, variable importance, corrects this problem. And again, you see a couple of citations over here. And the first author of this paper on unbiased permutation variable importances is standing here next to me in this picture, which was taken on a hike together with Fritz Leisch. This is Fritz here. And two of his former PhD students, Theresa Schall and Bettina Grün. Bettina Grün is also co-editor-in-chief of the Journal of Statistical Software. And 2 years after this picture was taken, Caroline put this ring on my finger. And 2 years down the line, she secured us 2 jobs at the same university. So we continued working together and co-authored 2 other packages, which, for obvious reasons, we host privately. Okay, so what is the common theme here? The common theme is that all these packages are working according to a Lego system. Right? You have different building blocks and software that you can put together, and identifying and implementing such frameworks is much fun. And actually, Kurt Hornig introduced us to this line of thinking. So us is mainly Achim and myself, and we are still trying to recover from this experience. The good thing is you can, it gives you a certain freedom, and this is very important, that the analysis or statistical analysis is not constrained by what the statistics cookbook and the specific implementation the stats package gives you, but you can define the analysis yourself. Okay? And sometimes the computational details just boil down to calling MBT norm. Okay, and then I stepped into the same trap as Francis Fukuyama, who declared the end of history in 1992, and we know that, unfortunately, this was not the case. So after 14 years of development, I felt safe enough to put the version number 100 on this package, and I declared, okay, this is the end of history, APA is frozen. We are going to maintain this package, but there's no new functionality going into this package. And then these three chaps landed on my desk, not literally, but in form of data. So the three aquatic birds here share the same environment and therefore aging on roughly the same fish species. And one of the questions ecologists are studying if there is competition between these species. And if they're competing for the same resources and do they actually interact? Can we see in data that something is going on? And the data I'm going to present, or maybe the models I'm going to present, have been derived from data which were recorded as part of a citizen science project. And there was only one science citizen, I don't know, Gerhard Kinshofer, who collected the data from 2002 to 2016 by going almost every day, there are very few missing values in this data set, to this lake called Seehamer See, and he spotted, following a specific procedure, the number of birds of these three species and recorded the data. Those of you who go back by car to Munich will actually come by this lake. So you see the highway over here. So we are somewhere here. This is Salzburg, and Munich is over here. So when you travel tomorrow or on Friday, appreciate the effort that this local ontologist actually put in here, so we can have this nice presentation. Okay, so, well, co-occurrence translates into correlation in statistics language. So poor man's approach of analyzing this data maybe could be a moving window candles tau. Okay, so I picked the first 2 years of every year, just put all the data together, computed candles tau, and then moved on for a week. So the second week, third, and so on and so forth. Okay, and then we have the bivariate correlations. So the blue line is the great nested crab and the cormorant. And then we see that over the course of a year, something seems to happen. Right? So early in the year, so January, February, the correlation is relatively high, drops to 0 in summer, and then over fall, there are wild patterns. And the question, of course, is this real? Is there such a signal in the data? Can we maybe get rid of these extremely ugly bumps? There are even empty spots here. It's impossible to compute candles tau for the data because there's so few data. And well, the answer is we can, and this brings us back to the polychoric correlations that I mentioned earlier. So I realized that someone writing an email 20 years ago already pointed out a problem that I will have 20 years down the road. And okay, so one way of modeling this, I'm not saying it's an optimal way, I'm not saying it's the only way. One way of modeling is to assume a latent Gaussian copula. Okay, we say, okay, there's a Gaussian copula working in the background, generating the data. Now, the data, of course, are counts. And this latent Gaussian copula may change, or the parameters of this Gaussian copula may change over the course of a year in a specific way. Okay, so, and the entity we are interested in is this conditional multivariate distribution function. Okay, so the y are the counts, three-dimensional in our case, and then we have the year and the day of the year as explanatory variables. And we write down the model in a way that we have a Gaussian copula over here, so that's just a three-variate normal multivariate CDF. And then we have a specific transformation of these counts, which may depend on year and day of year, and also a variance-covariance matrix, which may depend on day of year. This is our research question, right? The question is, do these correlations fluctuate? And unfortunately, the likelihood is this probability. So this is count data, so the probability of observing these counts on a specific year or day of year in a specific year. And this is exactly one of these nasty multivariate normal probabilities we started with. Okay, so this is work with my former PhD student, Luisa Barbanti. And the thing that I said to her was, okay, there's this package. Just fetch this package and try if you can optimize the corresponding likelihood by just plugging this PMV norm function in. Answer is you can't. Okay, so I failed because this procedure was not invented for such an estimation, or the implementation was not ready for such an implementation procedure. Now, okay, so we started from scratch, and then one thing that is important in these models is that you get the marginal distributions right. Okay, so the marginal distributions here look a bit weird. So we are applying a specific transformation which has a like fixed transformation for every component, and then a scale term for day of year and a shift term for day of year, and then an offset for the corresponding year. So and this tries to get the marginal fluctuation of the occurrences of these birds basically covered. And then the Gaussian copula is also parameterized in a bit of a weird way. So what we want to have in the end is this variance-covariance matrix. Actually, what we want to have is a correlation matrix, because we need a constraint that the diagonal elements are 1, because otherwise this term here would not be identified. Okay, so what we do is we go back to this Cholesky factorization. So this is the Cholesky factor. And then we write this Cholesky factor in a bit of a weird way, such that we can parameterize the model in terms of a lower triangle unit matrix. So the parameters of the model are these lambda parameters, and they are unconstrained. Okay, so it's guaranteed by this formulation that whatever the value of these three guys is, this is a proper correlation matrix. Okay, and then the shift and the scale and these inverse Cholesky terms are modeled by superpositions of sine and cosine waves, ensuring that the curves meet at December 31 and January 1, right? You don't want to have a gap at the end of the year. Okay, and the transformations themselves are modeled by polynomials in Bernstein form of order 4. Okay. Good, so the off-diagonal elements here of this correlation matrix are exactly the polychoric correlations we are looking after. Okay, so this is the model fit. And luckily, it basically brings back the same pattern that we saw before. That's good. They are smooth, that's also nice. Okay, so all the jumps are gone. And we can now, because I have a full likelihood, test if these correlations are actually varying over the course of a year. So I also computed a model which has these lambda parameters constant, so not depending on day of year. And when we run a likelihood ratio test against comparing these two models, then likelihood inference tells us, okay, there's probably something going on in this data. Okay, and then we can go back to the ecologists and discuss these results. Okay, so there is, since last year, the 1.2 series of this package. It introduces a new class LT matrices for lower triangle matrices, and multiple of them, many of them if you want, because we need them to represent these L matrices which depend on day of year. And here we have nearly 5,000 observations, so we need to keep track of this zoo of 5,000 lower triangle matrices, and there is an object that tries to do this, and it comes with methods. So you can, for example, compute the inverse of all these matrices simultaneously, so vectorized, so to speak. And the core of the new functionality is in the, The core is here in these two functions. So this is the log likelihood of the multivariate normal distribution, allowing for discrete data, for continuous data, and mixes thereof. And the discrete part is approximated by a new implementation or re-implementation of Erlangen's original 1992 procedure. The important thing is, however, this little function here, which gives you the score function. And that's instrumental for speeding up the optimization here. Okay, without the score function, you're basically lost. There's no hope that you can fit such a models in reasonable time, but with the help of the score function, this becomes finally possible. Okay, so the code was re-implemented. It's completely new, and in a way that it's suitable for optimization. And the good thing is that a major chunk of the original Fortran code busied itself with the generation of these quasi-Monte Carlo schemes. And in the meantime, I mean, 20 years is enough time for a new package to emerge. So in the meantime, this QRNG package was published, and it provides easy access to such sequences, Holton or Sobol or Korobov, and you can actually now play with these things. So the original implementation only had the Korobov rules. And I want to mention that, and maybe a detail here, that the whole software was written using the literate programming paradigm, which was invented by Donald Knuth for the art of computer programming. And I learned about this at the USA 2016 keynote in Stanford. And I wrote 2 packages following this paradigm, and my limited empirical evidence is that the ratio of bugs per line code are the smallest across all my other packages. So the NuWeb system, NoWeb or NuWeb, I'm using the NuWeb implementation, brings together theory, low-level code, R code, R tests, and R examples, and the documentation in one source file. So sometimes, I'm just mentioning this because we have heard about many, many new developments guiding and helping us to write better software, but sometimes it might be worth a look back into the 1980s, where also similar things have been invented. Okay, and then the next Lego system, of course, is on the horizon, generalizing this model that I just presented for the aquatic bird species. We call it multivariate transformation models, coupled with a likelihood procedure, so it's a multivariate most likely transformation. And the idea is to describe a conditional multivariate distribution, which may depend on covariates, by a Gaussian cupola after a certain transformation, and with possibly covariance parameters which depend on covariates. And this model is rather general. It's sometimes referred to as a non-paranormal model, but there are also connections to DAGs, to normalizing flows or optimal transport. So it's a very interesting thing to study. And well, the Lego system is already there. You probably can't use it because it's barely documented. But the way it works is that one fits univariate models from this tram universe to each of the outcomes, and then plug everything in this MMLT function together and use this formula interface to specify the dependency of sigma on X. And this works for continuous and discrete and sensor data and then combinations thereof. Okay, so now we can play Lego again using such a system. And I recently came across a very, very interesting paper on dependent censoring. So as you all know, the famous Cox model makes this assumption that the dropout times and the time to event are conditionally independent. And that's an assumption we all believe, because otherwise you can't fit the Cox model. And then there is this famous Tsiatis paper, 1977, Proceedings, National Academy of Sciences, saying, okay, you can't identify the joint distribution. Okay, we don't even try. And Ingrid van Keilegom and her co-workers recently demonstrated, actually we can. There are conditions that this joint distribution is identified. And well, I was curious, and well, it's almost as simple in software as writing down a Cox model for the time to event you're interested, time to death or whatever. And then you write down a Weibull model for the time to drop out. Okay? And then you feed everything into this MMLT function. This gives you the Gaussian copula, and you can identify the marginal or identify and estimate the marginal parameters and also the correlation. In fact, it's not quite that simple, because you have to deal with administrative censoring, but there's a very small function calling compris, because there's a connection to computing risk analysis, which does the job. So it's very little work, but had to be done. What you gain is a full likelihood approach and standard errors. So the original authors had to resort to a bootstrap procedure for assessing variability, and this is something you get for free. Okay, so the importance of these Lego systems are both visible or appreciable from a theoretical and a practical point of view. So what you can do is you can use these systems and plug together new or old procedures, fit the corresponding models, and compare them to maybe existing implementations, or use this model if no implementation is readily available. And I picked 4 random publications from the Journal of Statistical Software where one could actually try out such a thing. The downside is that neither of these models is, of course, optimized. And then it happens, like it happened to me yesterday, that you run into people and they here at this conference and immediately start to complain about, okay, your software is too slow. And my answer always is, you're looking at the wrong time scale. So computing time is just cheap, right? So if the computer needs 5 minutes to fit such a model, just go fetch a coffee. But me being able, or hopefully all the other being able to put together a model like this one here in, I believe, half a day, saves a lot of development time, because otherwise you're basically starting from scratch, implementing the likelihood function and so on and so forth, checking optimizers and other stuff. Okay, so the objective rationalist, and we all hopefully are objective rationalists, we need to be able to roam a rich landscape of models, because these models represent our hypotheses, and we want to get rid of these hypotheses, right? And therefore we need to fit these models, we need to be able to criticize them and maybe improve them in favor of a new hypothesis. So the identification of such model frameworks that allows us to do this in an as broad and as painless way as possible is extremely important. So this facilitates innovation in silico, so you can invent new models, not first with paper and pencil, but first with software, and then maybe evaluate them theoretically later on. And I think it is very important that we as users build such infrastructure, because this guarantees that the software is actually helping us. The software we are designing is there to make our jobs more efficient and more fun. And it's not the aim of this software to replace our jobs, and it's actually theoretically impossible to replace the objective rationalist by whatever intelligent machine. However, we need, and there have been many discussions, many presentations at this conference here, we need better understanding of how to keep this zoo of models not only in check, but also how we can communicate with them. So just CoEF and VCoEF and predict is not enough, and unfortunately all the packages that I presented come with their own understanding of what the model is and how the model talks, how these models talk to each other. Okay, so I think I could make a case that long-term package maintenance comes with a lot of benefits, both for the developers and also for the users. Occasionally it comes with some headaches, at least for the developers, but I guess also for the users. And it's now time for you to start your own long-term package project, so that you're ready to give the 2048 user keynote lecture then. I don't want to end this lecture with this cliffhanger here. So the question is, did my father actually switch to R? And I hesitated bringing up this topic and the picture that we'll see in a minute. I was not sure if it's appropriate to put the family album here on display, but Kelly paved the way yesterday, so I was very grateful to see her parents on the keynote presentation here. So here are my parents, my father and my mother, and we actually had a family trip to the USR 2006 conference. So he did switch. But I doubt that me jumping around with this MVT norm package did the job. I think another argument was much more important. So he was teaching biostatistics at the University at Hanover, and many of his students came from the Global South. And the argument that convinced him finally was that it is maybe not appropriate to teach students data analysis using a system they will probably never have the money to purchase a license for. So this open and freeness of R was finally the argument that made the case. And in some way, when I wrote this slide here, I thought he might have been ahead of us a little bit at this time, because there is much more room for bringing users from all continents together. We have seen presentations here, Latin R, also there was a presentation from Africa, which I think is very important, because R is not just number crunching statistical software. We've learned that R is a community, and I also think that R equips open societies, or those groups who are on the way to such a society, with an open data analysis software, which is instrumental from telling facts from fiction, and is therefore instrumental in defending or setting up liberal democracies against their enemies. And there comes Popper again with his notion of the open society and their enemies. And I beefed it up a little bit because Popper in the 1960s, of course, could not have appreciated the importance of open and free data analysis software. So to sum up, I think that we need to do more to communicate across the globe and bring together user communities from all areas. And maybe, or this is the hope, this also brings us back, maybe, and closer to this utopian world the internet and free software movement promised in the 1990s, right? We thought that this would make the world a better place, and we thought that if we communicate with each other, we can create more value, and that's true, but we all know that another world is unfolding before our eyes, thanks to social media, totalitarianism, and big tech. And I think we have to fight this. Thank you very much.
Thank you so much, Torsten. That was so riveting and eloquent, the way you described the journey of the software before and now, and sharing the letters that you receive about the package. I think it really caught our attention. I don't know how you feel about a question from the audience.
Sure.
Yeah, great. That would be, we're so happy for that. Who has a question for Torsten? No takers? Oh, we have one.
Thank you. Great talk. Very nice to see what comes all with this responsibility of being responsible for a package for that long time.
I can't promise the kids.
Okay. Not those. Not these packages, okay. So my question would be, what was this moment where this email hit you while you were on vacation? The closest moment of being repelled at some point?
No, as I said, so I read the email when I came back from my holidays, and it's always a bit, I'm checking, so I don't know, if you look at the daily summary of the Siren checks, and I look at this web page once a day, maybe twice a day. And typically I try to run a clean ship, so I don't want to say, I have one warning that I can't get rid of. This comes from some LaTeX problem on macOS somewhere. So that's probably okay. But I don't freak out, but I feel uneasy if there's too much going on. Okay, so, and if this comes, to your desk unannounced, it's a bit of a surprise because it's one of these additional checks. And then, how should I say? I mean, receiving an email from Brian Ripley is still, after the many years, not something that I experience on a daily basis, and I also appreciate that.
That's great. Oh, we have a question on the left-hand side there. Thanks, Emily.
Thanks for the great presentation. So if we go 20 years backward, so what would you say? I would have done it in a different way.
Oh, that's a very tough question. So I don't regret anything. But I think with a bit more... So I said in the beginning I had all the time of the world on my hands, which was of course not true. Right, so I mean there was a PhD project that I had to run, and later on you just have a job. So the development of these packages for a very long time was just on the side. It was neither as expected nor encouraged, and so you had to squeeze out the time from somewhere, from some chunk of your work, and that meant you had to make compromises. So you didn't look that closely into details as would have been probably appropriate. And this is probably reflected in some of these packages. So we cut some corners. We just have to either live with it or refactor the package if we are not happy with it. But in general, so what I have to say is I invested, of course, some time into these packages and also our activities in general, but I got back much, much, much more. And that's the main message to everyone in the audience. We are not doing this because we're just altruistic, or because we do this because it's fun, and we do this because we think it's necessary, but we also do this because a lot comes back. Just the fact that I'm able to pull one of 20,000 packages solving the job that I'm just at is just incredible. Even after 25 years, it's just unbelievable.
And that was really my follow-up question with how do you sustain the fun? How do you polish the reasons of why you keep doing this?
Well, for me, so when I work as a statistician, it's always very hard to see the outcome or the impact of my own work. So most of the time we are just writing things on paper. And I don't know if anyone reads these papers or what comes out of these papers. Right? And with software, I have the feeling that I'm producing something that I can't really touch it, but it has the notion of a tool. So you can do something with it. So I can do something with it, and other people can do something with it, and that carries some satisfaction.
Certainly, thank you for sharing that. We have one question over there.
I was wondering how you plan for the future. I assume you're not going to be a maintainer of MVT norm forever?
Yes, I would like to be maintainer of MVT norm forever. Yeah, so very important is, as I mentioned, Henrik. So the more people are involved in such a project, the more problems are also, or the more chance of balancing out problems is also there. And yeah, of course, I still feel, I'm a bit shaken by your question actually, because I don't, I don't feel that old right now, but yes, it's a valid point. Answer is I have no idea.
That's certainly a very good question. I'm wondering what is the impact of your, I guess, your friends in R in sustaining you? Do they give you more work or more sustenance? How often do you get together and do you tend to create new problems together?
Yeah, so I think one of my friends, Achim Zales, who's somewhere in the room here, it's very hard to meet him. Oh, over there he is. Very hard to meet him because when I want to relax, just having a beer and chatting away, then he says, he goes along for a couple of minutes.
For the beer? And
no, but the beer not, but the chat. And then he says, by the way, we still have these things on the to-do list that we need to talk about. And but it's not exclusive, right? It's part of the deal.
It's business and
it's not business. To a very large extent, we enjoy what we are doing, and that's of course very nice.
Yeah, that's great. Any more questions from the audience? We have maybe chance for like a couple more questions. So, one's coming over here, and then you, John.
So maybe also coming back to the question just before about like how old nowadays R is. I mean, I have to say for myself, I've only been working with R for 5 years, and coming to this conference, I realized even more how established it already is. And a question that I would ask myself when I also saw those pictures where you were obviously like a young PhD student, right? So do you consider if there would be PhD students, like mid-20 guys having revolutionary ideas today about what should change about R, do you think it would still be possible for them to give these ideas and to change something about R?
Definitely.
Are we still as flexible as you have been?
Definitely. So all of these developments happened in package space. And in package, but this is just the Wild West. You can do whatever you want. As long as R command check is satisfied. No, definitely. That's so the notion that you come to an established crowd of people who are just satisfied with what they achieved and just want to keep things the way they are, that's I think is a very inaccurate impression. I think we all want this project to continue, and this means constant change.
Thank you for your question.
Thank you as well for a very nice talk. What advice would you give to young practitioners or developers of R, and especially those that reside within academia where there is all this uncertainty about what's going to happen, not just about their package, their life, their work, anything? Yeah, so remember the colleague that told me, okay, if you invest time in this stuff, nobody's going to employ you at the pharmaceutical industry. You just have to stand your ground. Okay, you have to do what you're good at and what is fun. That's important, okay? There is no way of projecting into the future. There's no way of following or planning a specific career path, at least in academia. I mean, you have to do certain things. You have to write papers, of course. But nowadays, with software, you're in good family, right? You can write papers about software. You write your software, you submit a corresponding academic paper to, I don't know, Journal of Open Source Software, and then you publish this, and this is just goes into your academic record. Okay, so, I mean, it's maybe fun for half a day and then hard work for the other half of the day, but I think it's important to not, I appreciate, and many of my students ask this question, and many of an academic career is just not, you can plan anything. You have to be open and you have to find your own way. And I'm sitting on many search committees, and that's actually what search committees are looking for. They don't look for impact factors, or they don't look for high, I mean, at least in my university, other universities might be different, but we are looking for creative researchers. and for methodologically sound research. That's important.
Thank you.
So for the future or for anyone right now, the compass is always have fun and do really good quality work.
Yes.
Would be your advice
Yeah.
to move forward to.
Yeah, maybe the other way around.
Good quality work first and then have your fun. If there's no more questions, maybe we can slowly come to a close. Let's thank Torsten for the generosity of your time
Thank you, Torsten.
and sharing your stories. Thank you, everyone. Thank you
Thank
so
you.
much, Torsten.
Thank you.
I will close with some last-minute housekeeping. You've been very patient, and of course, it's not easy. It's very easy to be patient with such a riveting and eloquent talk. So, posters are still up. Take your time to peruse, look at them. You can vote on the sched.com app when you sign in. Please vote for them until midnight, and please bring your badges when you go to the chamber music event, even when you get picked up by the volunteers. Otherwise, you will have to play music. So thank you, and have a nice evening.